Hello my friends and welcome back to the You Can Do TV channel. Welcome to a behind-the-scenes look at JMW India's comprehensive wire and cable manufacturing process, where precision engineering meets advanced technology. The journey begins with the upcast process, producing oxygen-free copper, OFC rods, known for their high conductivity and purity. These rods are essential for applications requiring superior electrical performance. Simultaneously, the continuous cast rolling CCR line manufactures fire-refined high conductivity, FRHC, copper rods. This method efficiently recycles copper scrap, aligning with sustainable manufacturing practices. Post-production, the copper rods undergo a bright annealing process. This heat treatment enhances ductility and electrical conductivity, ensuring the copper is suitable for further processing. For insulation, a paper covering process is employed, particularly for transformer applications. This involves wrapping the copper conductors with high-quality insulating paper, providing both electrical insulation and mechanical protection. An inline spark tester checks for insulation integrity, ensuring zero faults before the cable moves to the next stage. Next, tension-controlled payoff and take-up systems keep the wire movement stable, minimizing mechanical stress. A laser diameter gauge continuously monitors the conductor size, maintaining consistent quality throughout production. For color-coded applications, an inkjet marking system labels the wires during extrusion, aiding traceability and installation. Cables are then coiled or spooled automatically, depending on their type and customer requirements. Throughout the floor, real-time monitoring systems collect production data, helping operators maintain optimal parameters. Environmental controls ensure that temperature and humidity remain stable, reducing variability in insulation and extrusion quality. Regular calibration of critical instruments further supports consistency and compliance with industry standards. Quality assurance is paramount. The in-house R&D lab conducts rigorous testing, including spectrometry and oxygen analysis, to ensure each product meets stringent industry standards. In the aluminum division, the rod breakdown (RBD) process reduces aluminum rods to finer gauges, preparing them for various cable applications. The 7-bobbin skip stranding machine then twists multiple wires together, forming a single, robust conductor. This process enhances the flexibility and strength of the final cable. Finally, the 120 extrusion line applies a protective sheath over the stranded conductors. This extrusion process ensures the cables are insulated and protected against environmental factors. Through each meticulous step, JMW India exemplifies a commitment to quality and innovation in wire and cable manufacturing. At Havel's state-of-the-art cables and wires manufacturing plant in Alwar, the production process begins with sourcing the finest raw materials from trusted suppliers. These materials undergo rigorous mechanical and electrical checks before being drawn into wires, ranging from 8 mm to 1.6 mm. The wires are then stranded and compacted using advanced high-speed machines, ensuring reduced losses and optimal performance. A sophisticated extrusion line ensures uniform insulation, free of impurities. Multi-core cables are twisted and laid up using cutting-edge machinery, avoiding any tangential stress that could affect insulation. The cables are armored with aluminum or steel wires, providing durability and protection. Finally, the cables are sheathed with high-quality PVC, manufactured in-house for superior control and flame resistance. Each cable is tested for conductivity, flame resistance, and durability before being packaged for delivery, ensuring it meets international standards for safety and performance. The plant also uses advanced testing equipment to assess every aspect of cable quality, including thermal stability and chemical resistance.
The
production of electric motors is a precise and intricate process, and the fully automatic armature production assembly line is designed to ensure efficiency and quality. There are two main processes that can be followed depending on the client's requirements. In process 1, the line begins with shaft pressing, followed by end-field pressing and commutator pressing. Then, the armature insulation paper is inserted and the armature is wound. The commutator is then welded, and wedges are inserted before the armature undergoes testing. The line includes several specialized machines: a shaft pressing machine, end plate pressing machine, commutator pressing machine, armature insulation paper inserting machine, armature winding machine, commutator hot stacking machine, armature wedge inserting machine, and armature testing machine. In process 2, the process starts with armature insulation paper insertion, followed by winding and commutator welding. Wedges are inserted, and the armature is then tested. There are three types of conveyor systems available: S1, S2, and S3. S1 supports the armature on the armature shaft, but may cause damage to the shaft. S2 supports the armature on the lamination, offering protection for the shaft and producing lower noise. S2 is a conveyor plate to support the armature, ensuring the protection of the shaft, lower noise, and a more aesthetically pleasing appearance. Throughout the entire production process, automation plays a crucial role in maintaining consistency and high production speed. This ensures that each armature is produced with minimal human intervention, reducing the risk of errors and enhancing overall quality control. Each step in the production line is carefully designed to enhance performance, protect the components, and achieve the highest standards of quality and durability. When assembling automotive oil pump motors, consistency and adaptability are key. This fully automated assembly line is designed to handle multiple motor models, customized to meet specific production requirements. The process starts with wire winding and automated insulation removal, adaptable to various motor types. The insulation's length and appearance are inspected for conformity, while stator core components are assembled. Laser welding and marking follow, ensuring dimensional accuracy through code reading, roundness, and outer diameter checks. Components then move to the assembly station for pre-clamping, wire cutting, and additional laser welding at the oil seal station, with visual inspections throughout to detect any errors. To ensure quality, the system integrates reverse placement detection, missing component checks, and pressure monitoring. All production data is captured and tracked through an industrial control system, ensuring full traceability. Finally, a comprehensive motor performance test is conducted. The system operates at a cycle time of 25 seconds per unit, with model changeover in under 30 minutes and a yield rate of over 99%, making it efficient and reliable for high-demand production. In the world of brushless motor manufacturing, speed and consistency matter. This automatic winding machine uses advanced needle winding technology to wind 14 strands of wire simultaneously, boosting stator production efficiency. After manual loading, the machine takes over, clamping the mold, winding the coil, then clamping and cutting the wire. It precisely positions the needle to align with each stator slot before winding begins. Once winding is complete, the machine automatically shifts to the next slot without manual intervention. Multi-tap winding is supported and fully programmable through the HMI, where operators can also set the number of stator slots and coil turns. Parallel winding of multiple strands ensures tight, uniform coils. Built-in remote diagnostics add a layer of support and control to the entire operation, making the system suitable for high-speed BLDC stator coil production. Get a glimpse of the cutting-edge production process at TES for electric rotating machines. The first step involves accurate laminations, followed by welding to ensure robust construction. The components are then machined to exact specifications before winding and assembly complete the electrical parts. After a thorough quality check, the products undergo rigorous testing in a specialized test field. Finally, the machines are painted for durability and dispatched to customers. Each machine is tailored to meet specific customer needs, blending mechanical and electrical technologies for superior performance. This advanced approach guarantees reliability and efficiency in every unit produced. Every electric motor, stove, and pump produced at Pulsei Electromash tells a story of innovation and craftsmanship. With over 70 types of motors manufactured, this plant utilizes advanced technologies from the foundry to the assembly line. The process starts with the creation of high-quality castings, followed by the meticulous crafting of rotors and stators. Specialized coatings and careful assembly ensure that each product meets stringent standards for energy efficiency and reliability. The company's offerings range from explosion-proof models for hazardous environments to custom motors for unique industrial needs, ensuring optimal performance in diverse sectors. Each step in the production process is designed to deliver machines that perform flawlessly under demanding conditions. The company's commitment to excellence is reflected in its continuous investment in cutting-edge technologies, ensuring that Pulsei Electromash remains a leader in the industry. From advanced design to high-efficiency motors, fan production at this hardware-based facility runs on innovation. The journey starts with sourcing reliable components, followed by a 7-tank pre-treatment process that prepares fan surfaces for flawless coating. Electrostatic painting, both liquid and powder, is carried out using advanced systems, including equipment imported from Switzerland. The plant's CNC-controlled copper winding machines reduce rotor-to-motor gaps, boosting performance. It also stands out as the only facility in India to offer in-house winding of portable fan motors. Automated assembly lines streamline motor production while ensuring consistency across batches. Each motor undergoes stringent testing protocols to verify performance under various operating conditions. Every unit is assembled, tested, polished, and packaged in-house, ensuring each fan meets high standards of efficiency and durability. Explore the precise production process at Toenphat 2 Copper Pipe Factory, where craftsmanship meets technology. The process begins with high-purity copper ingots, which are first melted in a high-temperature furnace to remove impurities. The molten copper is then cast into billets, which are cooled and prepared for further processing. These billets are carefully heated to the ideal temperature for extrusion, a process that forces the copper through molds to form pipes of various diameters. The extruded pipes are then quenched in water to solidify the shape. After cooling, they undergo a process of annealing, where the pipes are heated again and slowly cooled to enhance their flexibility. The pipes are then passed through a series of dies, gradually reducing their size and shaping them to precise measurements. Afterward, they are drawn through a series of drawing machines, where the pipes are pulled to achieve the desired thickness and length. To further shape the pipes, they are fed into a specialized machine that coils them into tight circles, allowing for easier handling and transport. After final inspection, the pipes are packaged and readied for distribution, ensuring they meet the highest industry standards. Picking copper, tucked away in a 19th century workshop in Ohio, still crafts copper goods using methods nearly unchanged since 1874. The process begins with large rolls of raw copper sheet, which are cut using patterns to create the rough outline of each item. These pieces are hand-shaped and joined with a brass and borax mixture applied at the seams. Once heated, sometimes to over 1,800 degrees Fahrenheit, the material melts and fuses, forming solid joints. The piece then takes a dip in an acid bath, removing oxidation and preparing it for shaping. What follows is a meticulous hand-hammering process known as planishing. This step not only gives the piece its signature texture, but also strengthens and hardens the copper in ways machines can't replicate. D-Picking remains the only workshop in America to perform this stage entirely by hand. Next, a custom-shaped steel rod is formed into a rim and carefully fitted to the vessel's lip. Each piece is unique, requiring individual attention. The item is then buffed and polished until it gleams. Despite the antique tools and aged workbenches, each kettle or drum that leaves the shop is built to last for generations. Even today, their products are used around the world, from candy-making kettles used by brands like See's Candies to orchestral timpani drums crafted for export. Every hammer mark and polished curve reflects hours of hands-on labor. In a time when manufacturing is often automated, this workshop continues to honor craftsmanship, proving that the old way still has a place in the modern world. Many of the workers are multi-generational artisans who learned the trade from their parents and grandparents. A single piece can require 6 to 8 hours of work, sometimes longer depending on the size and detail. Each finished product carries not just function, but the spirit of tradition, made to be treasured, not just used. It's a legacy forged in fire, shaped by hand, and passed down one generation at a time. Discover the intricate process of creating the Henning Koppel pitcher, a masterpiece by Georg Jensen. The journey begins with a flat sheet of silver, which is carefully shaped by hand using traditional tools and techniques. The design, first created in 1952, was once considered nearly impossible to execute due to its organic, sculptural form and highly polished surface. The pitcher's creation demands precision and skill, as each piece of silver must be flawlessly shaped to form its elegant curves. Decades of expertise are evident in every hammer strike, as the silver is shaped to perfection. Despite the complexity of the design, each pitcher is unique, with slight variations that reflect the handcrafted nature of the work. Throughout the process, the challenges and rewards of silversmithing are highlighted, emphasizing the personal connection between the artist and the tools they use. The result is not just a functional piece, but a timeless work of art that reflects Georg Jensen's commitment to craftsmanship and modern design. The dedication to the craft shines through in each meticulously shaped curve, showcasing the beauty of true craftsmanship. Watch as Bonner Master Roofing expertly installs double-lock copper roofing on a home in Media, PA. The process begins with careful preparation of the roof surface, followed by precise measurements for custom-fit copper panels. The panels are then meticulously shaped and interlocked using the double-lock method, ensuring durability and weather resistance. Each panel is carefully secured in place to form a seamless, elegant finish. The use of copper not only enhances the aesthetic appeal but also guarantees long-lasting protection. With an experienced team and attention to detail, this roofing installation combines functionality and beauty to stand the test of time. The result is a durable, beautiful roof that will not only protect the home for years to come, but also add a touch of timeless elegance to the property. Binding wire, essential in construction for securing rebar, is manufactured through a detailed multi-step process. It begins with raw, low-carbon steel rods. These rods are first loaded into the hot bonding wire drawing machine, which stretches them through a series of dies, reducing their diameter while improving tensile strength. After the wire passes through the machine, it is cleaned and treated with a furnish to enhance its durability and prevent rust. This step ensures that the wire is ready for use in construction as it meets the required standards. The final product is coiled and ready for packaging, ensuring it is efficiently distributed to construction sites for use. With its increased strength and rust resistance, the wire is ideal for securing rebar in a wide range of construction applications. The entire process ensures a high-quality, reliable product that meets industry standards. Stripping copper wire doesn't need to be messy or wasteful. This machine efficiently separates PVC or plastic sheathing from copper cables without burning, preserving up to 30% more weight. Designed to handle sizes down to 32 millimeters, it automatically adjusts the feed and includes a reverse action for jams. As a bonus, even the stripped PVC can be collected for recycling, making every part of the process profitable. Step into the intricate world of aluminum recycling, where mixed scrap transforms into valuable resources through advanced technology. The process begins with collecting diverse aluminum waste, ranging from beverage cans to automotive parts. These materials undergo shredding using low-speed, high-torque machines, reducing them into manageable fragments. Subsequent sorting employs magnetic separators and eddy current systems to isolate aluminum from contaminants, like steel and plastic. A pyrolytic decoating phase then removes organic residues such as paint and oil, minimizing oxidation during melting. The cleaned aluminum is melted in specialized furnaces, producing high-purity ingots ready for reuse in manufacturing. This efficient process not only conserves energy, using just 5% of the energy required for primary aluminum production, but also significantly reduces environmental impact. Steel meets its match in aluminum bales weighing over 2,000 pounds. In this demonstration, the dual-shear M160, aptly nicknamed the Monster, rips through dense blocks of aluminum extrusion and siding. Towering 24 feet high and weighing 66,000 pounds, this two-shaft industrial shredder runs on 600 horsepower, making it one of the most powerful machines of its kind. With each rotation, the counter-rotating shafts tear into 1,138 and 2,394-pound bales, reducing them into small, manageable fragments within seconds. The shredder's efficiency lies in its slow-speed, high-torque design, minimizing noise and dust while maximizing destruction. It's a brutal yet precise process, where heavy-duty engineering meets real-world recycling demands. Watching the aluminum yield to steel is both mesmerizing and a testament to the power behind modern waste handling. At Automotive, aluminum extrusion begins with a carefully controlled process. The journey starts at the billet casting facility, where aluminum is melted and formed into semi-finished billets. These billets are then tested for their chemical composition through spectroanalysis. To enhance uniformity, the billets undergo homogenization in a furnace. Next, they are fed into the extrusion machine, where they are shaped into various profiles, ensuring precision at every step. Afterward, quality checks are conducted to guarantee accuracy. The extrusions are aged to improve their strength, followed by surface treatments like anodizing or mill finish. This process ensures durability and corrosion resistance. With a production capacity of 350 tons per month, Automotive delivers high-quality products, meeting both local and international standards. Their advanced machinery and skilled labor contribute to the efficiency and excellence of every product. Explore the world of high-quality copper wire and busbar production at Expert Cable Factory. The process begins with high-quality raw copper, carefully processed in specialized facilities to produce up to 800 tons of copper monthly. This copper, in grades M00 and M1, is then transformed into various products like copper wire, ranging from 8 to 25 mm, and soft and hard bus bars, up to 250 mm in width. The precision in processing ensures the copper retains its ideal characteristics, crucial for its conductivity and durability. Advanced machinery and strict quality control standards are implemented throughout the production line. The final products are engineered to meet various industrial needs, ensuring reliability and efficiency. Whether it's for cables or bus bars, every step in the process contributes to producing superior copper materials. The entire production process is carefully monitored to guarantee the highest standards of quality. This ensures that the final products consistently exceed expectations in performance and longevity. From continuous casting to high-voltage performance, every stage of conductor and cable manufacturing at this facility is engineered for scale and reliability. In Western India, 2 specialized plants handle aluminum and alloy rod casting, which is the foundation for various powerline conductors. These rods are then drawn into fine wires and stranded into multiple configurations, some with reinforced or clad steel cores, to suit high temperature and high load conditions. Meanwhile, modern cable production includes high and low tension electrical lines, elastomeric cables, and fiber optic systems. A unique electron beam irradiating facility ensures enhanced insulation and thermal resistance, crucial for renewable energy applications like wind and solar. Quality assurance is deeply integrated into every step, with cables tested under simulated fire and smoke to meet stringent durability standards. Across its sites, automated systems like SCADA-controlled filling for industrial oils ensure consistency in transformer oil and lubricants production, many tailored for ultra-high voltage systems up to 800 kilovolts. This network of advanced production empowers global infrastructure, from refineries and power grids to railways and telecom, linking innovation with real-world performance. At the core of cable insulation lies the 120 extrusion line. Copper conductors are continuously fed through the extruder, where molten polymer coats them uniformly. Thickness and concentricity are monitored in real time by precision sensors. After extrusion, the cable passes through a water cooling system to harden the insulation. The final stage involves synchronized winding, ensuring tension control and coil uniformity. Each step in this line is engineered for high efficiency, quality assurance, and smooth integration with downstream processing. Stripping 35 kilovolts non-strippable semiconductor layers demands control and consistency. This tool clamps tightly onto cables from 30 to 54 millimeters in diameter, removing insulation in one direction with an adjustable 0 to 1.5 millimeters depth, leaving a clean chamfered edge. This is how a high-voltage 11 kilovolts heat-shrink cable joint is installed, built for endurance, safety, and electrical integrity in the toughest conditions. The process begins by marking and scoring the outer cable jacket, followed by the removal of armor wires, bedding, and fillers. Mastic tape is applied over the inner bedding to prevent moisture ingress. Copper earth straps are positioned and secured over the copper tape screens using constant force roll springs. Next, the semiconductive screen is peeled back with care. A rat tail file is used to reveal the white XLPE insulation layer beneath. This step is critical and must be done without scoring the core. A mastic crutch wedge is then installed to block residual moisture. After that, medium voltage mechanical connectors are fitted, accommodating both copper and aluminum conductors. Primary insulation is removed using specialized tools. Once the conductor is cleaned, stress relief mastic and control tubes are applied and heat shrunk. Connector insulation tubes are slid into place, sealed with yellow mastic tape to fill gaps. A conductive tube is then shrunk over the joint to bond both ends. A copper screening mesh is wrapped, followed by a heavy-duty aluminum armor cage secured with worm drive clamps. Finally, outer dual-wall heat-shrink tubing is installed in 2 layers, with mastic seals between them. The result is a durable, weather-resistant cable joint, designed to meet BS 7888 and Senelec HD standards for high-voltage reliability. Every layer plays a role, from shielding and stress control to moisture barriers and mechanical protection. The meticulous sequencing ensures optimal performance across decades of service. It's not just a joint, it's an engineered safeguard for high-voltage continuity. The assembly of electric motors involves several intricate steps to ensure precision and quality. In this fully automated electric AC motor stator assembly line, each component is carefully crafted using advanced machinery. The process begins with the insertion of insulation paper into the stator slots, ensuring each stator is properly insulated for optimal performance. Following this, the stator coils are wound automatically, using a stator coil winding machine, which ensures consistent and precise winding. Once the coils are wound, they are automatically inserted into the stator core. Next, the stator coil undergoes pre-shaping, where it's precisely formed to fit the motor specifications. The stator coil is then laced through a 4-station process, ensuring it is securely held together and ready for final shaping. Finally, the stator coil undergoes its final forming, ensuring all the components are correctly aligned and ready for assembly into the complete motor. Sensors and automated controls monitor every stage to detect deviations and maintain accuracy. The entire line is synchronized to minimize downtime and ensure smooth transitions between processes. Consistent spacing, tension, and positioning during winding and forming are essential to motor performance and longevity. This fully automated assembly line is designed to improve production efficiency, reduce labor costs, and enhance overall quality assurance. By incorporating advanced automation, each step of the process is handled with precision, providing consistent results and high-quality electric motors. Crafted without fire, this copper helmet is a testament to pure skill and tradition. The process of making a copper helmet begins with the careful cutting of copper sheets into precise shapes. High-quality copper plates are first cut to the necessary size and shape. Once the pieces are ready, craftsmen use hammers to gently tap the edges, gradually rounding them into the desired curved form. This hand-forging technique ensures the helmet has its smooth, rounded shape without the need for heating. The entire process demands patience and precision, as each helmet is crafted by hand from start to finish. Throughout production, workers regularly inspect the parts to ensure consistency and structural integrity. The tools used are simple yet effective, relying more on skill than on automation. Each seam and curve reflects the care taken during fabrication, making every helmet slightly unique. After shaping the copper, the pieces are welded together. The different sections of the helmet are carefully aligned, and skilled workers perform the welding to ensure strong, secure seams. Once the welding is complete, the helmet is smoothed and polished to remove any rough edges or imperfections, giving it a refined finish. The result is a fully functional protective helmet. designed for practical use in scenarios where durability and safety are required. The combination of cold forging methods, accurate welding, and secure fastening makes this helmet not only robust but also reliable for real-world application. At the final stage, a specialized box-like structure is added to the front of the helmet. This piece serves as a reinforced face cover, allowing visibility while enhancing protection. Workers drill precise holes and fasten the component using screws, ensuring it stays securely attached under stress. No part of the helmet is heated during production, highlighting the craftsmanship involved in cold shaping and assembly. Before packaging, the finished piece undergoes a final quality check to confirm it meets all required specifications. The helmet is then cleaned and buffed to enhance its appearance and remove any surface residues. Once complete, it is carefully packed to prevent damage during transportation and storage. From raw steel wire to finished nails, each step in this manufacturing line is engineered for speed and accuracy. Welcome to the fascinating world of wire nail manufacturing. It all starts with steel wire rods, drawn to the required diameter using a wire drawing machine. The wires are then fed into a nail-making machine that cuts them to size, forms the head, and sharpens the tip. After forming, the nails are polished for a smooth surface. A vibratory separator filters out any defects. Finally, the nails are packaged and prepared for shipment. Watch the automated transformation of metal sheets into finished water heater tanks. The process begins with a sheet feeder that selects and positions metal sheets with precision. These sheets move into a rolling machine, where they're shaped into cylindrical bodies. A longitudinal welding machine then fuses the seam along the cylinder's length, forming the main tank body. Next, a radial welding machine attaches and welds the caps onto each end, completing the structure. Designed for efficiency, this line produces up to 70 units per hour, handling boiler diameters from 300 to 600 millimeters, and lengths from 600 to 1,800 millimeters. Once set up, the system operates continuously, minimizing manual intervention. Developed by Advinmak, this production line exemplifies custom automation tailored to industrial needs. Every step in the process, from feeding to welding, is optimized for accuracy, speed, and consistency. Every 15 seconds, a new water heater is built at this advanced manufacturing unit in Nimrana. The process begins with robotic fabrication of the inner steel tank, fully automated from steel decoiling and deep drawing to welding and leak testing. Robotic manipulators and transfer arms ensure seamless material flow between stages. A built-in defect detection and preventative maintenance system enhances product reliability. Compliant with Industry 4.0, the facility uses real-time OEE monitoring and energy-efficient MIG welding machines powered by inverter-based technology. The enamel coating and baking line is a zero-discharge process using clean PNG fuel. Tanks are baked at over 850 degrees Celsius, forming a durable glass coating that protects against corrosion from waterborne salts. Each tank undergoes 100% inspection and a 48-hour aging process before final assembly. The assembly line integrates robots for precision fastening, leak testing, and PU foam injection. Certified under ISO 9001, 14001, and 45001, the facility blends speed, automation, and sustainability at scale. Witness the artistry behind the creation of a seamless vessel at Gertine, where ancient techniques meet modern craftsmanship. Starting with a flat sheet of copper, the metal is first annealed to soften it. Then, the cold hammering process begins, with each strike shaping the vessel, ensuring it doesn't crack by annealing the metal after each round. Various hammers are used to sculpt the surface, inspired by the beauty of ancient Egyptian pottery. Once the vessel is shaped, a 23K gold leaf is gently applied to its interior, adding a final touch of elegance. The design itself merges Egyptian and Irish influences, creating a truly timeless piece. The final product is not only a functional vessel but also a work of art that reflects a blend of heritage and craftsmanship. Each creation is unique, a testament to the skill and patience required to bring such a piece to life. Molten polymer flows through a precision die, forming an insulating layer around the copper conductor. This is the heart of the 120 extrusion line. As the cable moves forward, it enters a cooling trough to solidify the coating. Sensors along the path monitor thickness and alignment, ensuring quality. The line ends with controlled winding, ready for inspection and packaging. See how AMAC McKean Limited demonstrates the advanced process behind their drum twister line. This innovative line is designed to twist cables with utmost precision. The process begins with raw cables being fed into the machine, where they are twisted together using automated mechanisms. Throughout each stage, the system carefully monitors tension and alignment, ensuring that the final product is uniform and strong. As the cables twist, they undergo thorough quality checks to meet strict industry standards. The line's design and engineering ensure high efficiency and reliability, producing cables that will stand the test of time. The machine's performance is enhanced by cutting-edge technology, ensuring minimal downtime and maximum productivity. The double-head manual coiling machine starts with feeding raw cables into the system. The machine coils the cables meticulously, ensuring uniform tension across both heads. After coiling, the cables undergo a final inspection before being packaged. This process guarantees high-quality, durable cables, produced with advanced techniques and constant quality checks. Designed for stripping main insulation from 10 kV to 35 kV cables, this tool combines slicing and rotary cutting with an adjustable blade angle. It handles insulation up to 15 mm deep and works on cables with a maximum rotary diameter of 220 mm. The blade is replaceable, ensuring continued performance across various cable sizes. From single wires to tightly bound copper strands, the ADTB 1250 double twist buncher transforms raw conductors into organized cable cores. It runs non-stop, twisting wires at high speed with precise control. This setup plays a crucial role in large-scale cable manufacturing, where consistency and mechanical endurance are essential. The copper tube manufacturing process begins with straight copper pipes fed into a punching-type end-forming machine. This machine reshapes the pipe ends to specific forms, such as flared, swaged, or sealed, based on refrigeration requirements. Multiple tubes are processed simultaneously using automated clamping and forming stations. Depending on the complexity, machines may have 1, 2, or multiple working stations. The finished tubes are used in air conditioners and refrigeration units. This cold forming process avoids heat, relying entirely on mechanical pressure to shape the tubes while ensuring uniformity, precision, and production efficiency. Rolling an edge on a copper bowl requires patience and skill. The process starts with shaping and cleaning the piece, then using a large raising hammer to carefully curl the edge. The artisan works around the bowl multiple times, gradually increasing the curve with each pass. A stake is used to support the bowl and help refine the shape. Planishing, the final smoothing stage, further defines the edge. Though small imperfections remain, the result is a sturdy, hand-shaped copper bowl, ready for further finishing or functional use. Inside this advanced manufacturing plant, aluminum billets are transformed into precision components for the automotive and HVAC industries. The extrusion process shapes the metal under high pressure, followed by cooling, cutting, and surface finishing. Every stage is optimized for strength, efficiency, and consistency, delivering high-quality parts that meet international standards. Witness the inner workings of the BOST series rigid strander line, engineered for precision and performance. Designed for copper and aluminum, this system operates with motor-controlled pintle movement and synchronized rotation, ensuring stable and efficient wire stranding. Each cage, available in 6 to 24 bobbins, rotates at high speeds, up to 281 revolutions per minute, depending on configuration. Gearbox-driven and equipped with dynamic air sockets, it maintains consistent output. A laser-controlled tension system guarantees uniform wire tension throughout the process. The automatic safety cabinet adds protection without interrupting workflow. Supporting real diameters of AW 560mm and E 630mm, this line complies with DIN 46397, adapting seamlessly to varying production demands. Discover the expertise and innovation behind the aluminum manufacturing process at PT Indal Aluminium Industry. Starting with high-quality aluminum billets, the material is extruded to create various profiles, which are then anodized for enhanced durability and resistance. Next, the aluminum undergoes a painting process for protection and aesthetic appeal. The final stages involve fabrication and assembly, resulting in products such as windows, doors, water tanks, and solar panel supports. Creating a mixer motor armature requires accurate coil winding on hook-type commutators. This automated process uses the ND-Law 5, B2 and 5, B4 machines to handle medium to large wire diameters. Each armature is positioned and wound with accuracy, ensuring uniform turns and tight winding. Automation reduces manual effort while maintaining consistent quality across every piece produced. The result is a reliable component ready for integration into high-performance mixer motors. We'll uncover the craft behind raising a copper bowl from a flat sheet in this captivating demonstration. Beginning with a simple disc, the metal is first sunk to create a shallow base, setting the stage for the raising process. Using a hammer and anvil, the artisan gradually shapes the bowl, striking the metal with precision and adjusting the piece to maintain an even curve. Each hammer blow contributes to the creation of smooth sides and edges, while the technique of setting the edge ensures the bowl's strength. This process highlights the skill and patience required to transform a flat sheet into a stunning copper vessel. Take a journey to the Copper Museum in Legnica, Poland, where traditional craftsmanship comes alive. In this demonstration, a flat copper sheet transforms into a vessel using the age-old technique of raising. The process begins by annealing the copper, heating it to soften the metal for shaping. A hammer and stake are then used to methodically strike the sheet, gradually forming curves in depth. After each round of hammering, the piece is annealed again to relieve stress and maintain malleability. This cycle repeats multiple times, with the metal slowly taking the shape of a bowl or pot. Precision and patience are key, as each strike must be deliberate to ensure uniformity. The smoothness and symmetry achieved without the use of modern machinery reflect refined technique passed down through generations. To keep the form consistent, each section is worked in phases, gradually lowering the walls of the vessel. Adjustments in striking angles are made as the piece deepens, requiring careful observation and control. Sometimes, the workpiece is flipped to access different contours, ensuring an even rise from all sides. The sound of hammering itself becomes a rhythm, guiding the process and revealing subtle feedback from the metal. Small irregularities are corrected early to avoid distortion in the final shape. Finishing touches include trimming edges, smoothing surfaces, and a final anneal to relax the structure. The final product stands as a testament to the enduring art of copper raising, connecting us to centuries of human ingenuity and craftsmanship.